Okay, so as we spoke about the indexes yesterday,
Yeah.
what does an index do is the main purpose of creating an index on a table is to help SQL Server scan the table faster. Meaning, like if the table doesn't have an index, it would go and scan the whole table to return the filtered rows for you. But when you create an index, that process becomes faster. Now let me explain to you the concept of B tree, because that is what lays under the index logic. So basically, B tree means a balanced. B stands for balance. If you take a look at this picture, this is a demonstration of a B tree. So basically, when you create an index on a certain column, index will divide that values rows into pages. So imagine this, each one is a page. This is a page, this, all of them are pages. And the point is, whenever you search for any data, whenever you filter the data in a table, it will execute like 4 steps. Okay, you see 1, 2, 3, and 4. That's why we have 4 levels. Okay. So the first page is called a root level. Okay. And then the next pages are called intermediate levels, and then there's the leaf. If you imagine like a tree, because this concept is called be a tree, and if you can imagine this thing as a tree, so this is like an upside down tree. Okay. It has the root, and it has the trunk of the table, which is the body of the table, and then it has the leaves. Okay, so the table, I mean, as just like a tree, this B tree also has leaves. Okay. So now, now let's go here, and I will try to explain it to you in simple words. So B tree. Okay, this is a balanced tree. Now imagine we have one table that has 1 million rows of okay. Imagine this is a table, and then we have this is the ID column, and let's say this is the name column, and then we have number 1, 2, 3, and 4, and then all the way down to million. Okay. So, and then names are A, B, C, D, E. Now, since there's million rows, if I want to retrieve the data, let's say, if I say select all from table, this table, where ID is say higher than 100,000, and or let's say ID is between 100,000 and 800,000. Okay. Now we have this SQL select statement. So without an index, if I execute this, since I'm saying filter the rows by the ID, where the ID is between 100,000 and 800,000. Basically, I'm saying the ID should be higher than 100,000, but less than 800,000. Okay? So it will go row by row. It will go to first row. It looks at 1, compares it to 100,000. This is less than 100,000, so it will not take that row. And it goes to row 2, and the same thing happens because it's less than 100,000. It doesn't take that row, and it goes so on. And then when it reaches the 100,000, ID number 100,000, it takes that. Then it will go again and again, so 100,001, so it's higher but less than 800,000. So it will scan all of the rows until it reaches 800,000. Okay? Then it will select only those rows that are between 100,000 and then 800,000. So this process is a very costly process. Like scan is a very costly because SQL Server has to go through each row and then compare the value in each row to the filter. And now let's imagine now we created index on the ID column. Okay? So now, when we create an index on ID column, what happens is it divides all these values into pages. Okay? Into say balanced pages. Each page will have same number of certain number of rows. Let's say the first page would have all of the rows from 1 to 1 million. Okay? And then in the second level, the second pages will have all the rows from 1 to, let's say, 200,000. And the second would have the rows from 200,001 until 400,000. And so the next one would have from 400,000, from 400,001 until 600,000. Okay. And then the next one would have from 600,000 to 100,000. And then the next one would have 100,000 to 1 million. Okay? And then each of these pages, now these are the pages, right? Now each of these pages are also divided into smaller pages. Now this the pages that come from this one, it would have numbers from say 1 to 100,000 and 100,000 to 200,000. Okay. If we take a look at this example, you see in here, so basically the number of the rows is 200. There's 200 rows. Okay? So this page has all of the rows from 1 to 200, and then they divide this page into 2, and now this page has from 1 to 100, and this one has from 101 to 200 again. And then this will get divided into 2. This page will have from 1 to 50, and this one will have from 51 to 100. And again, this page will have from 101 to 150, and then this one will have 151 to 200 again. And then now this also get divided from 1 to 25, 26 to 50, 51 to 75, 76 to 100, and so on. Okay? If you take a look at this, basically what we're doing is we are taking something big and then breaking it into smaller pieces.
Yeah.
Okay? And now when I execute that SQL statement, let's say if I say select all from this table where ID is ID equals to, say, 120. Okay. So now what it will do is when I execute it, it will come to this page first. It will look, okay, we have 120, so this one contains the rows from 1 to 200. Okay. Okay, it will say, okay, it's in this page, and then it goes to this 2. Okay, it comes here. It has basically now this has from 1 to 100, and it has 101 to 200. 120 is in which page is the 120 now, you think?
120, 101 to 200.
Yes. So now SQL Server doesn't go here, but it will go this way. Okay. 101 to 200, and then again it comes here, 101 to 150, 151 to 200. Now where's the 120?
101 and 150.
Yes, so now it goes this way, and then now we have all this 101 and 125, and 26 to 50, 51 to 75, and so on. And now where is the 120?
120 here, 125. Yeah, inside of it.
Yeah, so we have the 120 inside this page, right?
Yeah.
Now when it comes here, this is the leaf. So now it has to only scan only 25 rows only. You see?
Yeah.
So instead of scanning 200 rows, now it can only scan 25 rows.
Yeah.
So that way it makes it fast. Okay. So what index does is it will just keep pointing the SQL Server to the right direction. Okay.
Yeah.
So any statement would take only 4 steps to be executed. Okay. It doesn't matter what you look for. You can only go 4 steps: 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. So you can complete the select statement in only 4 steps, no matter what you are trying to select, and no matter what the table size is. Okay.
Yeah.
Does this make sense to you now? Like this logic?
Yeah. Now it makes sense to me. But
Yeah. So
just in simple scan, in SQL scan, it goes row by row.
yeah, in simple scan there won't be any of these leaves. There will be only this one.
Oh, okay. Yeah.
Okay. So from 1 to 200. So since only this page exists, it has to scan from 1 to 200.
Yeah. It takes time. That's why.
Yeah, that's why it takes time, because it has to go through 200 rows.
Yeah.
But in this case, after step 1, 2, 3, the 4th step will be, it will only go through 25 rows from 101 to 125.
Yeah.
So it basically speeds up the SQL Server 4 times. Okay, instead of looking for 200 rows, now you're looking for only 25 rows. Actually, it's not even 4, it's 8 times faster now.
Yeah.
So this is the logic behind the indexes, how the indexes work, and this is the logic behind the B tree. In reality, there is no such thing as B tree. I mean, like anything like this, like there is no actual tree, or there is no actual, this visible pages. This all happen in a very low level, but this is the visualization of the concept, how it works. Okay.
Yeah.
So what happens is in reality, when you create an index, what happens is it will SQL Server, for example, you create an index for this column, right? SQL Server basically will copy that column, but inside the SQL Server now these values will not be like this. It will be something like, code, like say G for something, and then something again, something like this.
Yeah.
But we don't see those. And this will serve as pointers.
Mm-hmm.
Okay? So when you reach the last leaf, and now this is where the difference is between the clustered and non-clustered index, okay? So now if you understand this basic concept of the B tree, how it works, it basically jumps from one page to another according to the filter.
Mm-hmm.
Okay, so this is how the index works. Okay. Okay. Now, if you are, if this makes sense to you, now let's move on to types of indexes and how each type of index utilizes this B tree concept. Okay. They all use the same concept, same B tree, but depending on the type of the index, it will slightly change.
Yeah.
So for now, what you should understand is, okay, there's this something called B tree, and the structure of the B tree looks like this. It has the pages, okay?
Mm-hmm.
Each page has a certain number of rows or the pointers, okay? And now, like we have root level, intermediate level, and then leaf level, okay? Just like a tree. If you imagine this as a tree, now let's. I will try to do one thing. I will save this image. Okay. So that it's even more understandable. And now let's open this. So just imagine that you are trying to pick a fruit from a tree. Okay. So now does this look like a tree now?
Yeah, yeah.
Now,
It's like a
does this
tree,
look
yeah.
like a tree? Yeah.
Yeah.
So this is, it was basically the B tree that we saw was upside down. But this
Yeah,
is why they call it a tree. So this is the root.
yeah.
And then now imagine you have to pick a fruit from here. Okay? So pick a fruit, meaning that you're filtering the rows that here. So now instead of going all over the place, the easiest way would be you claim here, this node. These are the nodes, okay? This is the root, and these are the nodes. Jump to this node, and then finally you reach that leaf, okay?
Yeah.
Leaf of the tree. And then under that leaf, find your fruit.
Yeah.
Okay? Does this make sense now?
Yeah, sure.
So it's just like climbing a tree. So you just jump from one node to another, from another node to another until you reach your fruit. Okay?
Okay, yeah.
Okay. If now it makes sense, let's move on to actual types of indexes and go deeper inside the indexes. Okay. Okay. So today we will learn the different types of indexes in SQL Server, and specifically what are the clustered indexes, non-clustered indexes, and difference between clustered and non-clustered indexes. Okay. Basically, there is somewhere around like 10 types of indexes, but clustered and non-clustered indexes are the two main types. Okay, these are the two most oftenly used indexes. Okay, clustered and
Okay, yeah.
non-clustered index.
Okay.
Yeah. So, well, and these are the other types of the indexes also. So we have cluster index, we have non-clustered index, and we have unique index, and we have filtered, we have XML, full text, special, column store, index with included columns, index on computer columns.
Good. Yeah.
Are the all types of indexes, and we will be looking into clustered and non-clustered indexes.
Mhm.
Okay.
The article says about composite index.
So the composite indexes are also one type of indexes that we'll learn later. But for now, I will tell you the composite indexes are the ones that are created on multiple columns.
Oh,
Okay.
mhm.
So now let's say let's learn about the clustered index. So a clustered index determines the physical order of data in a table. For this
Yeah.
reason, a table can have only one clustered index. Okay. So now, what does this mean?
Yeah.
Okay. What it's saying is, so when you actually create a primary key on any column on a table,
Mhm.
you remember the primary key, right? It's a unique key. I mean, unique key, and it doesn't allow nulls. So when you create a primary key on any column of the table, a clustered index will be created automatically. Okay. Whenever you create a primary key, it also creates a clustered index on that column.
Yeah.
Okay. Unless there's already a clustered index there, it will create a new clustered index if you create a primary key. Now let's understand what does this part mean? The index determines the physical order of data in a table. And then for that reason, a table can have only one clustered index. Okay, what does this mean? Now, if we take a look at this, let's say example, if you see here, as I said before, these leaves are actually pointers. Like once you reach this last leaf, it will point you to the actual row. So these leaves don't actually store the actual rows, okay? This will they will have something like this, okay? This, for example, like behind the scene GUID like codes.
Yeah.
Or the pointers. And after you get there, this points to the actual row, and then you reach the actual data.
Yeah.
Until then, when you reach the leaf, it will only have these pointers. Okay?
Yeah.
And then you pick up that pointer, then the SQL Server will take you to the actual data and then select that actual data.
Yeah.
Okay? This is true for non-clustered indexes. So that is why it's saying create a clustered index. It determines the physical order of data in a table, because in a clustered index, when you reach the leaves, when you reach the actual leaves, you are actually data itself. So the leaves will contain the actual rows. Okay, and now why then it can only have one cluster index? The reason is when you create a clustered index, it orders the physical actual data in a certain order, like whether ascending or descending. Okay. So now imagine, yes. Now imagine this table. Now let's say we have this table, right?
Yeah.
And we have this data. Okay.
Mhm.
And when I create a clustered index on this ID column, it will reorganize data, the actual physical data. Like if I create a clustered index and say ascending, the table, the data inside the table will be actually ordered in an ascending order.
Yeah.
And the reason is, otherwise, whenever you insert data into table, right, it will be inserted in a random order. Okay. So the actual data in the table is all mixed.
Yeah.
It doesn't usually have a particular order. But when you create a clustered index, it will take all those rows and put in an order. Okay. But now the actual table, the actual data in a table is ordered.
Yeah.
Okay. The reason why we cannot have two clustered index one table is, imagine creating a cluster index in this ID column, and I'm ordering it ascending. So 1, 2, 5, 6, and so on. Okay. Let's say this is not ordered yet. Okay.
Yeah.
Let me put it here. So now we have this table. Okay. And this table is called a heap. Heap.
So it's
Yeah,
not clusters.
exactly. It's not ordered. It's a heap. It's all mixed up. It has the data starting from 0, 1, 2, and then 5, 6, and then again 3, 4, 7, 7, 8, 8. This 3 and 4 should be somewhere here, right?
Yeah.
But since it's mixed up, it's called a heap. The data is not organized in that table. Okay? So when I create a clustered index on this table, it will become something like this. Okay? Now it will become something like this. Now this is called a clustered table. Okay? Because now it has order. Okay?
Yeah.
You see, it's ascending. 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Okay?
Ascending.
Yes. And the rule says you cannot have more than one clustered index on table. And that makes sense because now imagine I have two clustered index, one table, and one clustered index orders the actual data in ascending order. Okay? And now imagine the second clustered index, if we were allowed to make the second clustered index, it will order the rows in descending order. Okay. Test this here. Now it doesn't make sense because SQL Server gets confused. Okay, how do you want me to organize the table?
Yeah.
Should I organize it in an ascending order or descending order? Okay.
Yeah.
It doesn't make sense to order one table in two ways at the same time, right? You can either order the tables ascending or descending, but you cannot have the same data ordered both ascending and descending. That doesn't make sense. That's impossible, right?
Yeah.
Therefore, you cannot have two clustered indexes on one table.
Yeah.
Okay? Because a clustered index physically orders the data.
Yeah.
Okay? It will change the physical order of the data in the table. Physical order means the actual order of the data in a table.
Yeah.
This we're just saying order by, and then descending, ascending, whatever. But this is not the actual order of the table.
Yeah.
The actual order is usually, if there is no clustered index, its table is usually a heap. Heap means it's all mixed up. It can have 0, 1, 2, and then 5, 6, and then 3, 4, 7, 7, 8, 8, for example. There is no particular order. Okay.
Yeah.
This is how the actual tables are stored in SQL databases. They are usually heaps, unless you have clustered index. Okay. And now, since I have clustered index on this column, let's say the ID column, right?
Yeah.
And this table is ordered, like actually physically ordered by the ID, and let's say it's ordered ascending. Now I don't need the pointers. I can actually straight away go here.
Yeah.
Because it's ordered already, and now let's say I'm looking for ID 5006 on like this 10 IDs. Okay. And now my B tree starts from here, from 1 to 11, and then here goes the 1 to 5, and here goes the 6 to 10, so on. And then when it reaches the leaf node, it will actually reach the actual table.
Yeah.
Okay? There is no pointers. It's the actual table when it's clustered index. Okay, and then it will actually select those rows that exist in the index itself.
Yeah.
Okay, so therefore it's called clustered index. Okay, so that is the reason behind a clustered index. It says determines the physical order of the data in a table. So it means it will actually reorganize the actual data in the table. So therefore, it becomes a cluster table instead of being a heap table. Okay? And then since a clustered index reorganizes the table, you cannot have more than one clustered index on a table because that doesn't make sense. You cannot have the same data ordered in two different ways at the same time.
Yeah.
Okay? So that is the reason why you cannot have more than one clustered index on a single table. Okay, and there is it says note that ID column is marked as primary key, and then primary key constraint creates clustered indexes automatically if no clustered index already exists on the table. Okay?
Yeah.
So whenever you create a primary key, this will also create a clustered index on that same table. Okay, now let's see that in action. Now let's say we in our homework database we have the salesman table, and then if I go into indexes, there is no index, right?
Yeah.
And there is no keys. So now let's create primary key. Okay. Well, actually, I guess we cannot create the primary key because there are already duplicate values here. Okay. You know what we'll do? We'll create another table with no duplicate values. Select distinct, all from salesman to select distinct everything. But now the select distinct, let's say ID. So now we have this distinct IDs.
Yeah.
And actually, you know what we can do is to make it distinct, we'll do this. I will, this is like an extra lesson for you. I will show you how to remove the duplicate rows. So now we have duplicates like 2 8, 2 7s, and all that, right? I'll say delete from salesman. Actually, you know what? Don't pay attention to this. I'll do one thing now, but we will learn this later, okay? But for now, don't pay attention to this, to what I'll do now, okay?
Yeah.
But you can just watch it, okay? So there's something called CTE, Common Table Expressions, and it's you can use that with when you want to remove the duplicates. Select all from salesman. Okay. So with CTS so select all row number over partition by ID by ID as RN, select all from CTE. Okay. And now what we'll do here is we'll do this, delete from CTE where RM equals to 2. Okay. And if I select all from salesman, now we should have distinct rows only. Okay. 1, 5, 6, 3, 4, 7, 8. Okay. No duplicates now. Okay. And then I'll delete this also, because the reason why what we're doing this is I want to create a primary key on this ID column. And ID column, I mean primary key column cannot have duplicate values or null, right?
Yeah.
Therefore, now I need to also remove the null. Delete salesman where ID is null. Okay.
Yeah.
Now we have this salesman table trimmed, and we have distinct values on the ID column, and we don't have any nulls. So now I can create a primary key on this ID column, right?
Yeah.
And before that, take a look at this. We don't have, as of now, no indexes and no keys on this table. So I'll say alter table salesman, add const pj id. It's going to be a primary key on ID. Okay. So now if I alter this, nullable column in table, can I define primary key constraint on nullable column? Yeah. So I guess it's a nullable column, so we'll again say alter table salesman, alter column ID integer, not I guess we're using this table in some sort of store procedure or something. Let's see. Columns, not no. You know what? I'll do this. As of now, we have select all from salesman. We have this. Select all. You see, now you will actually see when do we use the temporary tables. So now what I want to do is I want to take this data into a temporary table and then drop this table and then recreate that table and then insert this data back. Okay, so I need to hold on to this data somewhere.
Yeah.
Okay, so that's why I will do select all into, if you remember how to create the temp table, I'll say temp and then this. Okay, now I have this temporary table with the data. So now I can drop and recreate this table, salesman.
Yeah.
And when I drop and recreate this table, since I drop and recreate, it will not have data on it. So integer, and I'll say not this time, okay? Because this is what I want to change, right? I want to make it a not null column.
Yeah.
Okay, I dropped it and recreated it. Now I should have this salesman table, but there is no data, okay? Well, actually, why don't we just create the primary key here itself? Okay. Okay. Now let's select all from temp table. Into cells and from temp table. Now I want to put the data back from the temp table. Well, actually, you know what? Select all. Okay, never mind. So now what I wanted to actually show you is, so the salesman table, now it has a primary key, right?
Yeah.
And then if you take a look, we have also an index, clustered index.
Yeah.
See? And we didn't create the clustered index. Since we created the primary key, it created the clustered index automatically.
Yeah.
Okay?
Mm-hmm.
That is actually what I wanted to show you. But yeah, it was a long journey. Okay. And it says to confirm, execute SP help text employee table. Let's see that also. I mean, help. Help. Text. Salesman. Text. Help index. Sorry. So this is another system store procedure that will show you the indexes on a table. Okay. If you remember, we had also a help text. Now it will show you the indexes on the table.
Mm-hmm.
Okay. And so it looks like we have a unique non-clustered unique key located on primary key. We have non-clustered located on primary key. Okay. Salesman name and then salesman all this. This is showing that we have this. Okay, let's move on. So There's also a note that the values for ID column are not in a sequential order. If you, well, we should have checked that before, but let's see. One, two, 5, 6, 3, 4, 5, 8. Okay, so this is what we have in the salesman table now. Okay, let's drop this index. Okay, and just remember the order of the data in this table now. Okay,
Yeah.
So now we don't have index in this table. So if you look at this data, when I'm doing a select star, this is the order of the data, right? It's not in one order. Okay.
Yeah.
Now let's create a clustered index. Create index IX salesman ID, and we'll make it a clustered index. Okay. IX on salesman table. Okay, and ID column, and we want it to be ascending order. Okay. Okay. Now, if we take a look, we already should have the salesman. Do we have like 2 salesman tables or something?
Yeah.
Clustered index keys. Interesting why it's not showing the index on the table. We created that on salesman table. Let's see. On primary ID, you see it's showing that this index is there, right?
Yeah.
But I don't know, for some reason it's not showing it here. Let's refresh. Okay, never mind. Okay, now let's try to select everything from this table and see what happens. You see, now what happened is the index ordered the physical actual data in this table in an ascending order. You see? 1, 2, 3, 4, 5, 6, 7, 8. Okay. That when we selected everything from this table, before having the index, the table was a heap, meaning that all of this was mixed up. Okay, not in one order. But after we created this index, clustered index, on ID column ascending, now the actual data is in ascending order. Okay. Okay. So now, so this is what it means when I say clustered index actually organizes the data in the table.
Yeah.
I'm only saying select all from salesman. I'm not saying order by ID or anything, right?
Yeah.
This is the actual order of the data now in the table.
Yeah.
Okay. And now another thing. So indexes are good. It's helpful. It makes it fast and everything. But you have to be careful when creating indexes on tables, especially the clustered indexes. You know why? Because whenever you try to insert or update a table or delete something from the table, it makes it little difficult to do that.
Yeah.
Because when you insert a row into this table, and with them, let's say, with ID number 5009, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. It has to look through all this and then put it in its place, okay? Because since it's ordered now, it cannot just insert it right away. It has to first find out where should this row go.
Yeah.
Okay? Otherwise, if it was a heap, it would just insert the row after the last row and so on and so on. But when it's clustered index, it will be like, for example, you will have to look for the place to insert that new row, because it has to maintain that order, right? Now let's try that in action. Let's say insert into salesman values. Let's skip one and insert 5010, okay? And then we'll try inserting the 5009. Okay. Let's say name is ABC, CT is Tula, commission is, say, 20. Okay. Now I inserted this, and now if I select start from this, so 5010 is after 5008, because that's where it should be, right?
Yeah.
And now let's try inserting 5009. Okay.
Yeah.
DEF UFA 23. One row gets affected, and then I'll do this. And you see, this is inserting 5009 right before 10. Because, so this is why it's, you have to be careful when creating the indexes on certain columns, because even though it makes it fast statements, it might slow down the insert statements or update or delete statements, okay?
Yeah.
Because now if I try to insert this 5009, it has to look through this column and find where this fits. Okay, because it's ordered now and it has to maintain that order. So it cannot insert this 5009 after 5010. It has to insert it before that. So that's why it will compare this 5009, find the place before inserting, okay? That's why it could get a little slow with the insert statements or update statements, okay? Otherwise, if this table was a heap, then it would just insert this 5009 after this 10, okay? But since it's clustered index, it has to find a place for this. Let's see that also in action. Let me drop this index first, okay? And then try inserting some more values. Drop index, IX, salesman, ID. ID. How is the syntax? Sales. Let's try this. Okay. So now we dropped that index, right? Still organized, because that's how it was. Let's try inserting the one row that's 5012. Okay. So one row gets inserted, and if we select this 5012, we'll go after 10. That makes sense, right? And Now, if you saw before when there was an index, this 5009 got inserted before this 10, right? Because that's how the order should be, right?
Mm-hmm.
Now let's try inserting this 5011 and see if it comes between this 10 and 12, okay?
Yeah.
Okay, one row is inserted. And now you see, 5011 is coming after 12 now.
Yeah.
Because there is no index.
Yeah.
The data in the table is not physically ordered, okay? That's why it's easy when the table is a heap, it's easy to insert because it doesn't care where exactly to insert. It will just keep inserting to the next row. That's it, okay? It doesn't have to think and search for the place to insert this in a manner when it's a heap, when there is no clustered index on a table. So it will just insert it right away at the last row. Therefore, insertion is faster on heap tables. But when you have index, it's a little difficult to. It takes a little more time to insert data because SQL Server has to look through each row and find the correct place for that row.
Yeah.
So that's why you should be careful when you're using clustered index or any indexes. You have to be, you have to also consider this aspect also. Okay? Even though it makes it fast to select or filter rows, it might make it slow to insert rows into a table. Clustered index on a table. Okay. Okay. Now let's put back this index. And now if I select, it should order the table as it is now. So 10, 11, 12, it's good now. Okay. Okay. Now let's continue. That's what it's trying to say here. Note that the values for ID column are not in a sequential order. Okay.
Yeah.
It means that there is no index. But once you create the index, it will go in sequential order. 1, 2, 3, 4, 5. Okay. In this case, its insert is 3, 1, 4, 5, 2. There is no order. But once you create the index, it will go in an order. Okay. Okay, now let's continue. So a clustered index is analogous to a telephone directory. This we talked about yesterday. So for what it's trying to say is, so where the data is arranged by the last name. So like a table, especially not in a book, like not any book, but especially the phone book. The names, imagine the phone book, the names are ordered by the last names, right? So that is what clustered indexes. Okay. So you will have you will not have the actual index, right? In a telephone book, it's a big book, so you don't like there is no index page at the end of the book. But instead of that, the names are ordered in an alphabetical order. So if you know the last name, you know where to search. You just go look in one page. For example, if the last name is let's start with an S, and now you have this huge book, and there's like millions of people, names of people, and then where would you? And it's ordered in ascending order alphabetically. So where would you search for Simpson? You would probably go to the more last pages because the first pages would contain people whose last name is starting from A and then B and then C and then D and so on, and then the letter S is like around at the end of the book, right? So that's how the clustered index works. Since the table is ordered now,
Yeah.
in a clustered index, since the actual data is ordered, and when you say select start from this table where ID equals to 506, it will come and it will already know where to search for that row because it will take the whole count. Okay. Now, since we have 12 rows table, and if they're ordered, 6 should be in the middle, right?
Yeah.
Because there's 12 rows, and it's ordered from 1 to 12. 6 is half of 12. That's why it should be in the middle. So that's why SQL Server, when it's trying to retrieve the data for 5006, it will not start from the beginning or it will not start from the end. It will jump right in the middle.
Yeah.
Okay, that's why it's fast. Okay, so that's how the clustered indexes work. So we just learned that table can have only one clustered index. However, the index can contain multiple columns. So it's called a composite index. That the question that you were asking earlier. Okay. So like the way a telephone directory is organized by last name, first name. So basically, what it's saying is, now we know that a table can have only one clustered index, right? But that clustered index can be created on multiple columns at the same time. It will be only one clustered index, but it will have multiple columns.
Yeah.
Okay, so how do you do that? So you say, this is and that is called a composite clustered index. Okay, so when the index has more than one column, it will become a composite cluster index. So how do you create that? You say create cluster index and give it a name on table and then gender descending, salary ascending. So now we have the index on this column, this column.
Yeah.
Okay, let's see that in action. Let me put topic. Cluster indexes, and I'll say you can have one clustered index on a table. Clustered index organizes the actual data in a table. Okay.
Yeah.
So it will no longer be heap. Okay. So when you create, as we just saw, when you create the clustered index, it will actually order the data. Okay.
Yeah.
So it will not be a heap. Okay. And then I'll also put some more thing. Primary key automatic a clustered index. Okay. So basically, first thing is if you create a primary key, it will automatically create a clustered index. Second thing is you cannot have more than one cluster index on a table. So you can have only one cluster index. And then the third thing is clustered index organizes the actual data in a table. So the table will no longer be a heap. Okay? I will copy this also to above so that you already know where to create, how to create the index. Okay? And then this is I will put trivia. Okay.
Yeah.
How to remove duplicate rows from a table. Okay. This will come back to this later. Okay. For now, just it's like as I said, it's a trivia. Okay. And this is also an interview question. Remove duplicate rows. We'll go deeper inside to this when we learn the common table expressions. Okay. Now, this is the. I'll also put this here. Stored to see the indexes on a table. Okay. This is just select all. We learned this yesterday. So here is no alter table. This okay. This is just thing. Now let's create composite indexes. Okay. So the composite index is index with multiple columns. So these are indexes with multiple columns. Okay. So how do you create a index? Just like any other index, you will say create clustered index, and then now let's say so now we have index on ID column of this table, right? Let me drop that. Okay, now we dropped it, and now let's create the composite index, but this time let's create the index on multiple columns. So I want to be the ID column, and then also an index on name. Okay. Name also say ascending. And if I create this, it gets created successfully. And then if I take a look at this, now I can see. You see ID and name, it's a clustered index also, and since it has more than one column, it's considered a composite clustered index. So what is the difference? There is no difference. I mean, like in terms of how it works or the logic or anything. Only difference is this composite index can be created on multiple columns. Okay. Whereas the regular clustered index can be only created on one column. Okay. And this is not a separate type of index. Okay. This is just variation of the index. You see, when you create the index, we're not saying create composite clustered index, because there is no such thing as composite index. Yeah. This is just a type of the clustered index itself. So basically, when a clustered index has more than one column, it's called a composite index. Okay. Yeah. So I'll put that also here. This is not a separate type of index. Okay. Yeah. It's only a type clustered index. Basically, when a clustered index has more than one column, it's called a composite index. Okay? So this is not a new type of index. It's just variation of the clustered index. Basically, whenever the clustered index has more than one column, it becomes a composite index. So now let's say, so we now know that the difference is when there's more than one column, it's a composite. But how does that work? If you remember when we were creating a unique key constraint, you can create the unique key constraint on multiple columns also. But the difference is now, since we have this cluster index on this composite cluster index on this salesman table on ID and name column, so you can have duplicate IDs, but across ID and name, it has to be unique. Okay?
Yeah.
So when I take the ID and name together, this has to be unique. But the ID itself can be duplicated. For example, let's say as of now, we don't have any duplicate IDs, right? We have 0, 1, 2, 3, 4, 5, and so on. Now let's and now we have also clustered composite index. Now let me try to insert this 5011 again, since we have already one, but the name will be different. Say dolphin. Okay. I guess we also have the primary key on this column, right? Yeah, so yeah, that's why we cannot do that. And so I guess we have to also drop the consider primary key column and into not null double salesman. Okay, alter table salesman, and I'll say drop constraint, name of the constraint. Oh, it's not a constraint. Never mind then why it's not. Let's try doing this and key constraint, unique key. Oh, okay, we have a unique key constraint.
Yeah.
Okay. But for some reason it's not showing it here. Let's do one salesman, salesman two. We're reading the salesman table. Sample, table student. Okay, let's say unique key. Drop constraint, unique key. Okay, now let's try. Okay, we dropped the unique key constraint now. You see, now it lets us insert data with the same ID. Okay, now we have, you see, 5011 DEF, 5011 Dalton. These two are duplicate, but if you look at ID and name columns, these are distinct, right? Yeah. This is 5011 Def, this is 5011 Dolphin. These are two different things. Now let me try to insert the same thing again. Oh, I guess we dropped that unique also. Okay. Yeah, now our table is messed up. Now let me delete this from somewhere. ID equals to 5011. We'll get rid of this. Okay, now select everything from this one. Now let's see what do we have here. I think we made so many changes. I don't know what's where. Okay, we have a clustered index on this table. Okay, and now let's select this. We don't have 11. Okay, 0, 1, 10, 11. Okay, if we have the cluster index, it should go in between 10 and 12. Let's see if that happens. Okay, so it went through here. And now, oh, okay. I guess it will let me insert this again because we did not specify that clustered index as a unique index. Okay, we had to also specify that as a unique index. Let's see. Create cluster index. This is this is that. Let's copy this here. Drop index on salesman. Cluster. Let's try this. Unique. I don't know if that is the right syntax, but okay, it looks like create cluster index. Create unique index. Cluster unique index. Let's try that. Okay, it doesn't probably work. Okay, let's look up the syntax. Create unique clustered index. Primary key column cannot allow. Let's see this, the syntax. Create unique index. Okay. Okay. So unique index. Okay. Create unique index. Create unique index. Okay. Now we have the unique index. Okay. Now let's select what do we have on this table. We don't have this 11. Okay. Now we have this 11, right? 10, 12, 11, right? And then if I try to insert the same thing, 11, but different name, it will let me do that, right?
Yeah.
Because now if I take a look at this, 11 dolphin, 11 ABC, this is unique across these two columns, right? As long as it's unique across this ID and name, because when we specify the unique index on ID and name, it's okay to have it like unique across ID and name. But
Yeah.
now if I try to insert the same thing one more time, it will not let me do that because there's a unique index. You see, what it's saying is, cannot insert duplicate key rows in object with the unique index. Okay? So that's what a unique index does. But then, if I do, for example, let's say, so cluster index this and that. Now let's create the clustered index. So this was the unique index, but unique index can also be considered as cluster index. I mean, composite index because it has two columns. But let's create the actual clustered composite index. Okay. I don't know if it lets me do that now because I think we have duplicates on the ID column, but let's see what it says. Okay, failed because an index or cell with the name already exists. Oh, yeah. Let's drop this first. And now let's try to execute this. Okay, now it's good. Now if we select star, it should be ordered. Okay, 10, 11, 11, 12. You see, now this, so now we created this composite index, right?
Yeah.
It's a composite index, composite clustered index. But the clustered index actually should be unique, right? Since it's like it works just like on primary key, it should be unique. So if we have composite index on 2 rows, 2 columns, now it should be only unique across the 2 columns, okay? You can have duplicate values in one of the columns, but you cannot have the duplicate values across 2 rows, okay? You have 5011 ABC, 5011 Dolphin, but then you cannot have one more time 5011 ABC or 5011 Dolphin, okay? Then it becomes duplicate across these 2 columns.
Yeah.
Okay?
Mm-hmm.
Does it make sense?
Yeah, so should not duplicate, yeah?
Yeah. So clustered index, just remember the primary key. That is the criteria that works with cluster index also.
Mm-hmm.
So cluster index cannot be duplicate.
Yeah.
And if it's composite cluster index, it cannot be duplicate across those columns that are specified.
Yeah. Mm-hmm.
Okay, let's move on. And now let's talk about the non-clustered index. So basically, I guess it would be easier for you to understand if I told you that clustered index is the primary key, non-clustered index is the unique key.
Yeah.
Okay. If you remember, you could only have one primary key on one table, and the primary key cannot have duplicate rows and null. Whereas you could have more than one unique key on one table. So the same goes for the non-clustered index. You can have more than one non-clustered index on a table. These are very similar.
Yeah.
So now a non-clustered index is similar to an index in a textbook. So the data is stored in one place, the index is indexed in another place. So now, you see, you have to understand one thing. Phone book and the textbook, the difference between the phone book and the textbook.
Yeah.
Okay. Have you seen a phone book before?
Phone book, yeah.
Yeah. So in a phone book, actually there is no index page at the end, right?
Yeah.
Whereas in a textbook, there is an index page at the end.
Yeah.
Okay. So that index page of the textbook is not the actual data. That's just a pointer. You
Yeah.
go at the end and then you look up the page number for a certain chapter, and then according to that number, you go open that same page.
Yeah.
Okay. So the index is not the actual data, but it's actually a pointer that points you in the right direction.
Yeah.
Okay? This is how the non-clustered index works.
Mm-hmm.
Whereas clustered index, the primary key, right? The clustered index, it is similar to a phone book. A phone book does not have the index.
Yeah.
The phone book is organized in an alphabetical order. So when you are actually searching for someone, you're actually searching within the actual data.
Yeah.
Right? Like, so the phone book has the names of people and their phone numbers, right?
Yeah.
And when you're searching for someone, you are actually searching within the actual data, among those names and phone numbers. Okay, not the pointer. It's the actual names and phone numbers. But since it's ordered in an alphabetical order, you know where to search for which letter. Okay, that is the clustered index. Okay. So the clustered index, when you search, you are actually searching the actual data itself. In a non-clustered index, you first look up in the index page and find the pointer, and then actually go to that actual page after you have found the pointer.
Yeah.
Okay? So that is the reason behind this thing.
Yeah.
So when you have a non-clustered index, okay, when you start from this root level, you go here and then here, second level, and then here, and then when you reach the leaf level, the leaves, in non-clustered index, these are the pointers.
Yeah.
So the non-clustered index has to go one more step to the actual data when it tries to select the actual data. Okay? Because it's, as I said, it's just like an index page of the textbook. It will only have the pointers at the end. And then from there, you go to the actual page, right?
Yeah.
But in the clustered index, when you reach here, it's the actual data.
Yeah.
Just like the names of the people and their phone numbers. You go, like if you're searching for someone whose name is Thompson, you know that it will be somewhere at the end. You go for A, skip, and then you go somewhere D, and then you skip and you find the T, and then within that T you find that name. So this is the actual data in a clustered index. So the clustered index, when you reach the leaf level, actually at the real data, actual data that you're looking for, instead of looking for pointer. For in a textbook, like for example, in a textbook, you want to open the chapter 10. You want to see the actual text in the chapter, to learn something from chapter 10. You want to read chapter 10, right? When you look for that, you go here, here, and there, and then you go to an index page. Then you look up the number for chapter 10. Because this index page will only tell you chapter 10, and the page number is, say, 100. This is not the actual data that you want to see, right? You want to read the chapter 10. You want to see what's in chapter 10, right? So once you find the page number for that chapter, you go and open that page.
Yeah.
So that's how the non-clustered index works. The last leaf is actually the pointer. From there, you go to the actual chapter 10, the information that you want to see. Okay? The non-clustered index in a phone book, when you're looking through the pages, you're looking at like the A's, B's, and the names start with the S and whatever. And then when you reach the names that start with the letter that you need, say T, you're actually looking at the actual data, actual names of the people and actual phone numbers, right?
Yeah.
Those are not the pointers. Those are the actual information that you are looking for. So that's in clustered index. When you are in this leaf level, you are looking at the actual data. Okay, so that is the main difference between the clustered and non-clustered index. This is very common interview question. When they ask you the difference, you should be able to explain this B3 to them. Okay, and the easiest way to explain that is the textbook and the phone book. Okay, so in a textbook, you go at the end of the page, you up the index, but that index does not have the actual information you need. Once you find the page number, you go to that page where the actual information is.
Yeah.
In clustered, when you reach that place, like in a phone book, looking at the actual information that you're looking for.
Alphabetical.
Yes, exactly. So does this make sense so far?
Yeah.
Okay, so that is the main difference between the clustered and non-clustered indexes. Okay. So a non-clustered index, that's why it's saying non-clustered index is analogous to an index in a textbook. Before, for the clustered index, it was saying it's a phone book. Now it's saying textbook.
Mm-hmm.
So the data is stored in one place, the index in another place.
Mm-hmm.
So that in a textbook, if you see that index page is separate, like at the end, right?
Mm-hmm.
And the actual information is like the rest of the book is the actual information.
Yeah.
So it's separated. You have one index page and separate 100 information pages. So the index will have pointers to the storage location of the data. So it will have only the pointers. It will have the name of the chapter and the page number. That's all.
Yeah.
Okay. So that's what it's saying. So since the non-clustered index is stored separately from the actual data, a table can have more than one non-clustered index. Just like how a book can have an index by chapters at the beginning and another index by common terms at the end.
Mm-hmm.
You see, what it's saying is since the non-clustered index is completely separated from the actual data,
Mm-hmm.
you have more than one non-clustered index because that doesn't hurt the actual data. It doesn't change the actual data. Okay?
Yeah.
Therefore, you can have how many ever non-cluster index on one table you want.
Yeah.
Whereas the clustered index has to change the actual physical order of the data in a table. It has to organize the data. That's why you cannot have more than one clustered index, because you cannot order the same table in different orders. Okay? So in the index itself, the data is stored in an ascending or descending order of the index key, which doesn't in any way influence the storage of data in the table. You see? So in the index page, it's stored just like this B tree, right? 1 to 200, and then 150, and this, and so on and so on. Okay? Or if easier, it would be easier to say that in this ID column, now it's stored in an ascending order, right? So that SQL Server will always know where to locate the row. Like if it's so how it does it, it will always have the number of all the rows. Like say there is only 13 rows, right? So now if I'm looking for 5004, and since this is ordered in ascending order, logically thinking the 5004 would be at the beginning, right? And when you're looking for 5011, you know that if there's only 13 rows and they are all ordered in ascending order, you know that 5011 is closer to 13, so it should be somewhere in the bottom.
Yeah.
Right? So that's how the SQL Server finds it quick.
Mm-hmm.
Okay? Because what it's saying is in the index itself, the data is stored in an ascending or descending order of the index key. Okay?
Mm-hmm.
What it's imagine I copied this column, ID column, right?
Mm-hmm.
And put it somewhere else. Okay? Now I have this ID column. Okay? Only the ID column itself, and I can order this in any way I want, and this will not change the order of this actual IDs.
Yeah.
It will make it easy to find this actual IDs.
Mm-hmm.
Looking at this one, right?
Yeah.
So that's what it's saying. It doesn't the actual order of data, you can have more than one non-clustered index.
Hmm.
Now it comes to second problem with the indexes. So the first problem with the indexes was that if it's a cluster index, it makes it a little difficult to do inserts or updates on that table because it has to find a correct place to insert that row, right? Second problem is the storage,
Hmm.
meaning if you have many indexes on one table, or many tables, many indexes, each index will copy a part of the actual data, right?
Yeah.
So now imagine you had this table only. Now you have this table plus this extra column.
Yeah.
And now imagine this is a big table with million rows. Now you have this million row table and then one more column with million rows.
Yeah.
That might create a storage issue.
Yeah.
Okay, it takes more space.
Yeah.
So that's why you should be very thoughtful when you're creating indexes on any tables. You should think first, how am I going to use this index? Or how the data in this table is usually used. Like if this is a table where they filter by or filter by salary or something every day, then it's wise to index on the salary column.
Yeah.
But it's not wise to put index on all of the columns because you don't use all of the columns at the same time anyway, right? So you have to be very thoughtful of using indexes. So basically, indexes are very useful of making it fast, like your select statements and all that. But on the other hand, they have these problems with statements and also the storage issue. Okay.
Yeah.
These days, storage is not a problem, but it's still,
Hmm.
And now the difference between these two. So the first difference is only one clustered index per table, because you can have more than one non-clustered index. So basically, again, we go back to that primary key and unique key. Just like those, you can have only one primary key on one table and many unique keys. Yeah. Just like that, you can have only one cluster index per table, and then you can have multiple non-cluster indexes. Okay? Then, clustered index is faster than a non-clustered index because the clustered index has to refer back to the table if the selected column is not present in the index. Okay?
Yeah.
Basically, what it means is it again comes back to that thing that clustered index. When you have the cluster index, you are actually on the when you reach that leaf level, you're on the actual data. So it doesn't have to go one more step. Okay. When in the cluster index, you come here and you are sitting on the actual data.
Yeah.
When it's non-clustered, when you come here, it's just a pointer, and then you go and open the open that particular page, right?
Yeah.
Just like those phone book and textbooks again, when you're skimming through the phone book by the alphabetical order, when you find someone, you're actually seeing the actual data. That's why you don't have to go and open the actual page. But when you're using the textbook index, you first search through the index, and when you find that page, now you have to go back to the book and open that page. There's one extra step to perform, right? That's why the clustered indexes are faster than non-clustered. And then the clustered index determines the storage order of rows in the table, and hence doesn't require additional disk space. Whereas a non-clustered index is stored separately from the table, so that means it needs additional storage space is required. So as we were looking at these clustered indexes, when we created the clustered indexes, it actually organized the data, the actual data, right?
Yeah.
So now it can perform its logic on the actual data. It can come, and if we look for this, it will know how many rows are here, and then it will know if it should look at the bottom or the top or in the middle, right?
Yeah.
But when it's a non-cluster index, it has to actually copy that column and save it somewhere else, just like index page of the book, right?
Yeah.
And then it should look up in that column, the index column, and then when it finds it, it has to go back to that table and find the same row here.
Mhm.
That's why it needs this extra storage for non-clustered indexes, okay? So that might also cause a problem if you have many non-clustered indexes.
Mhm.
Okay, so that's it. Does it make sense?
Yeah.
So does the better now, the indexes, if I...
Yeah. Now it's better. Yeah.
Okay. Good. Okay. So we'll finish it here. From next lesson, we'll learn the unique and non-unique indexes, the ones that I think we already touched them.
Mhm. Yeah.
I don't want to go further and, I want to go little by little with more complex topics.
Yeah.
Okay, because if we try to learn the other topic also at the same time now, I know.
You get confused. Yeah.
Yeah, you get confused. Okay?
Okay.
So